The question is calculate the mass of oxygen gas O2 required for the combustion of 702 grams of octane C8H18, and we have the chemical formula 2C8H18 plus 25O2. Those two react to give 16 CO2 plus 18 H2O. So let me write down the question. Calculate the mass of oxygen gas O2 required for the combustion of 702 grams of octane C8H18, and you're given the formula, you're given the balanced formula 2C8H18 plus 25O2, and that will produce 16 CO2 plus 18 H2O. Okay, so let's just label it. So we have 702 grams of octane, and that's this one here. So we have 702 grams here, and we want to work this out, don't we? But what we do know is that 2 moles of this will react with 25 moles of this. So let's work out the molecular mass of C8H18. Let's just write down the steps. So step 1, we want to work out we've got the mass of CHH18. So CHH18, we want to find the moles. Step 2, from there we can work out the moles of O2, moles of this. Step 3, we can use this to work out the mass of O2. So from the moles, we can work out the mass. Alright, so let's work out the molecular mass of CH. Molecular mass of C8H18. Now we know C is 12, H is 1. So because we've got 8 of C, so we times that by 12. 8 times C is 96, and we've got 18. So we've got 18 times 1 is 18. Add them up, we have 114. Alright, so we can work out the number of moles now. So we know that 1 mole of C8H18 is 114, and we have 702 grams. How many moles? It's about 6. It's going to be about 6, more than 6. So we got to divide. So 702, divide that by 114, and we get 6.157. 6.158. 6.158 moles of C8H18. Right, so now we have 6.158 moles of that. Now, if 2 moles react with 25, and we have 6.158 moles react with how many? That's the question mark. We need to find that out. So to find that out, we need to times this by 25, and then divide by 2. So 6.158 times by 25 divided by 2, we should get times 25 divided by 2, we should get 76.97. 76.97 moles of O2. So if 2 moles react with 25, this is from the balanced equation. Can you see that this is from the balanced equation? So if 2 moles react with 25, and we have 702 grams. Remember, we need to convert the 702 grams into moles, and we got 6.15 moles. Using the ratio of 2 to 25, we need to work out this missing part. So 6.158 to x, so we're going to call that x. So 2 times, this is roughly 3, right? So 2 times 3 is 6. So roughly that's going to be 75. So if we do 6.158 times 25 divided by 2, we get 76.97. So what does that mean? If we put it back into here, 76.97 moles of O2. So 6.158 moles will react with 76.97 moles of O2. Now we need to work out the molecular mass of O2, because then we can work out the mass, because we what was it, mass over molecular mass, molar mass equals moles. Rearranging, we get mass is equal to moles times molecular mass, or molar mass. I'm interchangingly them two. So the number of moles is 76.97 moles. And what is 1 mole of O2? 1 mole of O2 is now 1 oxygen is 16, isn't it? So 16 plus 16 is 32 grams. So it's 32 grams per mole. So if we times them together, this was already in a calculator, we times that by 32, we get answer 2463. So it's 2463 grams of O2. Alright, so we have a question. How many molecules of I2 are produced by the reaction of 0.4235 moles of CuCl2 in the following reaction? So you got 2 moles of CuCl2 plus 4 moles of Ki. Those two reactants producing 2 moles of CuI plus 4 moles of KCl plus I2. 1 mole of I2. So basically, how many molecules of diatomic iodine gas are produced by the reaction of 0.4235 moles of copper chloride in the following reaction? You got 2 moles of copper chloride plus 4 moles of potassium iodide. React those two reactants producing 2 moles of copper iodide and 4 moles of copper chloride and 1 mole of iodine gas. So that's part A. And then for part B, what mass of I2 is produced? Alright, so let's underline this because it's talking about 0.4235 moles of CuCl2, and so that is referring to this. And the question is asking about how many molecules of I2. So I2, where is that in here? That's this one here, isn't it? So now, if you look at the numbers in front, so that's 2, and that is 1, imaginary 1. So, do part A. So, can you see 2 to 1? So, This is because it's talking about copper chloride. Copper chloride, number in front is 2, and then it's about how many molecules of I2, and so the number in front here is imaginary 1, so it's 2 to 1, and we have 0.4235. We want to work out this missing number. So what is this missing number? So we just half it. So it would be 0.21175 moles of I2. The question is how many molecules? Well, we know that 1 mole is 6.022 times 10 to the 23. So if we have 0.21175, we times that by 0.21175. So we have 6.022 times 10 to the power of 23. And we times that by 0.21175. The answer is 1.275. 1.275 times 1.275 times 10 to the 23 molecules. Now for part B, because we have the number of moles already, which is this part here, which is at the top, so 0.21175 moles of I2. Now let's work out what 1 mole is first. So 1 mole of I2 is, now in the periodic table, if you look in the periodic table, just one I is 127. Now because you got 2 of them, you double it. So you have 254. So 1 mole of diatomic iodine gas, 254 grams. And because you have 0.21175 moles, you times that by that much. So you have 0.21175, multiply that by 254, and you get 53.78. 53.78. 53.78 grams. Okay, let's have a look at this really fracking hard one. So we have sulfur sulfadiazine burn cream, and it creates a barrier against bacterial infection and releases antimicrobial agents directly onto a wound. What mass of sulfur sulfadiazine, and the chemical formula is AgC10H9N4SO2, can be produced from the reaction of 73 grams of silver oxide Ag2O and sulfadiazine C10H10N4SO2. Now you're given the equation Ag2O plus 2C10H10N4SO2, and that produces 2AgC10H9N4SO2 plus H2O. So the question is, what mass of silver sulfadiazine? Alright, so I've underlined the 73 grams of silver oxide. So this is 73 grams. Let's just write the number of moles. So if we write down moles here, so we have 1, and here we have 2, here you have 2, and here you have 1 mole. So 1 mole of Ag2O plus 2 moles of this, and that will produce 2 moles of this and 1 mole of H2O. Okay, so that's the number of moles, 73 grams. Right, so let's work out what 1 mole is of Ag2O. Alright, so we have all the data here. So we have silver is 108, carbon is 12, hydrogen is 1, nitrogen is 14, oxygen is 16, and sulfur is 32. So if we work out 1 mole 1 mole of Ag2O, we will have 2 lots of 108 plus oxygen 16. So that is 216 plus 16. That is equal to 232. So we've got 232 grams for 1 mole. So how many moles is that? Well, how many moles is 73? So we do a fraction. So we do 73 divided by 232. So we get 0.3146. 0.314655 moles. And if we look at here, the ratio is, because the question is asking for sulfur, silver sulfur diazine, which is this one. So can you see the ratio is 1 to 2? So if we times that by 2, we get 0. Let's just say that's about 0.63. Okay, so now we need to work out the molar mass of that. So what's the molar mass of Ag C10 H9 N4 SO2? So Ag is 108 plus 10 lots of 12 plus 9 lots of 1 plus 4 lots of 14 plus 32 plus 2 lots of 16. Alright, so I've added it up, so you should get 357 grams per mole, and we've got 0.63 moles there. 0.63 moles. So if 1 mole is that many grams, and we want to work out 0.63 moles, we times that by that, don't we? So times by 0.63, you should get about 225 grams. Actually, let's just make it more accurate. 224.9 grams.